Good morning, students. Today's I am going to discuss some theorems related to chapter 10. Okay, so theorem 10.1. The theme of the theorem is equal chords of a circle. Equal chords of a circle subtend equal angles at the center. Equal chords of a circle subtend equal angles at the center. So in the definitions in the previous lecture I to explain chord. A chord is a line segment joining any 2 points on the circle. So look at here. To prove this theorem we follow first write the theme of the theorem, then the figure. So here is the figure, here is the circle. O is the center of the circle. And what the question asking, what the theorem asking? Equal chords of a circle. That means given conditions are two chords are here, equal chords, so many chords. So here AB and CD are two equal chords. Okay, to prove this theorem we take at least two chords here. Here AB, chord AB is equal to chord CD. So give him that chord AB is equal to chord CD, right? Here O is the center of the circle. Equal chords of a circle subtend equal angles at the center. What you prove? To prove angle AOB is equal to angle COD. We have to prove it. Angle AOB is equal to angle DOC or COD, right? So these two chords are equal. Construction is not required here. Actually, to prove any theorem we sometimes need construction because of the given conditions are not sufficient, but here the given conditions are sufficient to prove this theorem, right? So no need to do construction here. So now proof now. In triangle OAB and triangle COD, okay, OA is equal to OC, right? OB is equal to OD. Why they are equal? Because they are radius. You already known in the previous lecture. Okay, radius is a line segment joining center to any point on the circle. Okay, there are 4 radius, all are equal. And AB is equal to CD. Equal chords given equal chords already given here. Chords AB is equal to chord CD. So that implies triangle OAB congruent to triangle COD by what? SSS congruence rule. And after congruent, you know that the angles opposite to equal sides are equal by CPCT. So that implies angle AOB is congruent to angle DOC by CPCT, corresponding part of a congruent triangle. Hence proved. So what we prove here? If we in a circle the chords are equal, then equal chords of a circle subtend equal angles at the center. Means the angle subtended by these chords at the center are equal because they both are equal here. Thank you, students. Now come to the next theorem. Theorem 10.2. just opposite to 10.1. If the angles subtended by the chords of a circle at the center are equal, then the chords are equal. Okay. In theorem 10.1 tells that equal chords subtend equal angle at the center, but theorem 10.2 it is just opposite to 10.1, conversion of theorem 10.1, that if angles subtended by the chords of a circle at the center are equal, then the chords are equal. That means in this given figure, according to this theorem, first draw a figure here. This is the given circle with the center of the circle. Here are the two chords, chord AB and chord CD. They are not equal, but the angles subtended by them at the center are equal. So AOB and DOC are the angles subtended by these two chords at the center. So given that angle AOB is equal to angle DOC, this is given, and to prove, what you prove? Chord AB is equal to chord CD. No construction is required here. Only given condition is sufficient to prove this theorem, right? So proof here. Just we go to proof section. In triangle OAB and triangle ODC, OA equal to, what you write? OA equal to, we just write OA is equal to OC, AOB angle is equal to angle DOC, okay, then OB is equal to OD, right? So these are the as radius of the circle, is also as radius of the circle, and these are the given condition as given. So by side angle side congruency, OA equal to OC, side, both the angles are equal according to the given condition, and OB is equal to OD, also radius. So that implies triangle OAB congruent to triangle ODC by side angle side congruence rule. So that implies, after congruence, you know that the sides opposite to equal angles are also equal. Here in the theorem 10.1, after congruency, the angles opposite to equal sides are equal. But here the angles are, in this given theorem 10.2, angles are equal. Angles subtended by the chords at the center are equal, and we have to prove that the chords are equal, of equal length. So after congruency, it is congruent. Now these two triangles are congruent by side angle side congruence rule. So after congruency, what happens? The sides opposite to equal angles are equal. This is known as by CP/CT. So chord AB is equal to chord CD by, what you write? By CP/CT. Hence proved. Okay. So using these two theorems, you solve exercise 10.2. Okay. So in the next lecture, we solve some questions from the exercises. Let me explain the next theorem. Theorem 10.3. What is the theme of the theorem? The perpendicular from the center of a circle to a chord bisects the chord. Okay, so first draw the figure. The perpendicular from the center of a circle to a chord, that means here is the circle and O is the center of the circle, right? The perpendicular from the center of a circle to a chord, yani AB is the chord here, AB is the chord, OP is the perpendicular. So given condition is, what is given here? Here OP perpendicular to the chord AB. And what we prove? The perpendicular OP drawn on AB, the chord, bisect the chord. That means P be the midpoint of AB. That is AP is equal to BP. We have to prove it, right? So look at here, students. This is given condition. Now to prove. AP is equal to BP. We have to prove it, right? So for the simplicity, again we draw here. This is O and this is AB chord and this is OP. It is given that OP perpendicular to AB. Students, here construction is required, as given conditions are not sufficient to prove this theorem. So construction, just join OA and OB. Join OA and OB, right? So these are the what? These are the radius to this circle. Now prove it. In triangle OAP and triangle OBP, okay, what you get? OPA angle OPA is equal to angle OPB as perpendiculars, means we write 90 degree, right? OA is equal to what? OB. OA is equal to OB as radius to the circle. Construction, from construction we get here, from construction, right? And OP is the common side for both the triangles. Look at here, OAP and OBP. OP is the common side, so this is as common side. So that implies triangle OAP congruent to triangle OBP by what? Right angle, hypotenuse. The side opposite to right angle is known as hypotenuse. So OA and OB are the hypotenuse to these two triangles and any side OP. So RHS congruence rule. So that implies what we get? AP equal to BP by CP. These are the corresponding sides, okay, because these are the two angles. So opposite to these angles are what? Opposite to these angles are the two sides AP and PB. These are the corresponding sides. So what you get? The perpendicular drawn from center to any chord bisect the chord. Yani OP is the perpendicular here. It bisect the chord. Yani that means P is the midpoint to the chord AB. AP is equal to BP. So hence proved. Okay, students. Now come to theorem 10.4. Theorem 10.4. Just opposite to this theorem. The line drawn the line drawn through the center of a circle to bisect a chord is perpendicular to the chord. The line drawn through the center of a circle, that means circle is drawn is necessary to prove this theorem. O is the center of the circle. The line drawn through the center of a circle to bisect a chord, that means AB is the chord, P is the midpoint here. P is the what here? P is the midpoint here. The line segment joining center to the bisect chord, that P is OP. We prove that OP is the perpendicular bisector, and that means perpendicular to this chord. We just prove it. Just before the theorem 10.3, the perpendicular, OP is the perpendicular drawn from center to any chord, bisect the chord. We proved here P is the midpoint of AB. Okay, but in this cases just opposite to 10.3. Opposite to 10.3 theorem. The line segment joining center to the bisect chord is perpendicular to the chord. We prove that here. Given AP is equal to BP and O is the center of the circle. O is the center of the circle, right? Clear, students? What we prove? To prove OP perpendicular to AB, that is OPA equal to OPB equal to what? 90 degree. So construction is required also here. Construction is required here. What is the construction? Join OA and OB. So join OA and OB. Join OA and OB here. Right, students? Okay. So now prove it. So take these two triangles, compare these two triangles. In triangle OOP and triangle OBP. In triangle OAP and OBP. OA is equal to OB. OA is equal to OB as radius. From construction we get as radius. From construction we write. Okay. Then OP is equal to OP as common side. It is the common side for both the triangles. We are discussing here OAP triangle and OBP triangle, common side. Then next one is, and AP is equal to BP, given here. Given. So now these two triangles are what? Congruent. Triangle OP congruent to triangle OBP. By side congruence rule. So after congruency, what our aim? We prove that OP perpendicular to AB. So OPA angle OPA is equal to angle OPB. So that implies angle OPA is equal to angle OPB by CT. So now OPA, angle OPA, look at here, angle OPA, OPB is equal to what? The sum of the two angles. This is a line, OPG, what? Any ray. So positively these are the linear pair angles we say, 180 degree as linear pair angle, right? So as we already proved that OPA equal to OPB, so can I write in place of OPA and OPB as twice of OPA? Yes, we write as angle OPA equal to angle OPB. Right, students? So OPA equal to 180 by 2. So OPA angle is equal to what? 90 degrees. So what you get? So that implies OP perpendicular to AB. So hence proved. So what do we conclude here? We conclude that the line segment joining center to the bisected the chord is the perpendicular to the chord. Okay. So today I explained 4 theorems to solve the exercises questions. I think you all understood me. Thank you, students.